Alright guys, limiting reagent is no different than the other problems, except there's going to be a third factor here, and we are going to have competing things. Regardless, there's still going to be real world issues, and there's still going to be moles that are here, and that's going to have an issue because just because we have the moles doesn't necessarily mean we get to use all of the moles. So when we come down here for the moles, we're really going to be putting this into three different categories: a have, a used, and a leftover, as the case may be. So, first of all, let's see what they told us here. It says, how many grams of HF can be made? So what do they want? They want to know grams in the real world here. And what did they give us? They gave us 4 grams here, and they gave us 14 grams here. Well, which one of those do I use? Do I use the 4 grams and work my way over? Or do I use the 14 grams and I work my way over? Now, there's a variety of different ways that you can do these problems. And you can get on Khan Academy, and you can go to all sorts of different teachers that'll tell you all sorts of different things. I'm not telling you that those things are bad and my way is good. I'm just telling you how my brain works. If you find a way that works for you, you go right ahead and use that method. It's not that I don't care. It's just, oh, no, wait, that is it. I want you to do what works for you. Now, I'm going to show you these problems the way that I do them because I think it does a very good job of keeping track of all of the different factors so that you can know how much you have, how much you used, and how much is left over should they ask for those particular factors. And there's only going to be one little wibbly wobbly bit in there where you're going to have to make an educated guess in the process, and you could end up being wrong. And if that's the case, then you just do the problem over. Again, some teachers will tell you just do these problems twice. Just forget the 14 and do the problem over here and figure out what that number is. And then in the second part, you just ignore the 4 and do the 14 and work your way over like so. And whichever one is less is the right answer. If you're cool with that, if you're cool with doing double the problem, then I'm cool with that. It really doesn't matter to me. However, you are not necessarily going to get access to other information that they could ask you about, so you kind of need to be careful with that. So what are we going to do? We're going to do the same thing we did before. We're going to get out of the real world and we're going to get into the world of the moles, except that we're going to use it, we're going to figure out how much we have. So to get from 4 to the moles here, we're going to have to divide that by 17 grams per mole. And that's going to get us about 0.235 moles that I have here. And to come from the 14 down, I'm going to have to use the 38 grams per mole for the F2. And that's going to be 0.368. That is there as far as moles that we have. Please again note that I have not taken into account the 5 or the 2 there. Those don't matter right now, but they're about to. So, which one of these do I use? Do I use the 235 to try to figure out what's going on over there, or do I use the 368? Because one of them is going to run out first. Now, in order to do these problems, you're going to have to make an educated guess to figure out which one you're going to run out of. And if you're wrong, it's really not that big of a deal. You just go back and do the problem over again. So maybe you look at this and you say to yourself, well, you know what? I think I'm going to run out of the 235 because there's less of it. Perfectly valid guess. Right? So let's see what happens. If I go ahead and try to use up all 0.235 of this, then I would be left with none of that. And if I use the 235 that's there, right, then that means I'm going to come across here by a ratio of 5 to 2. Because again, I'm going from the 2 over to the 5 that's there. So a 5 halves ratio. So I'm going to take the 235 and multiply it by 5 halves. And I end up with an answer of 0.5875 or so. Whoa, hold on. Time out. I only have 368. But in order to do this problem this way, I'm going to need to use 0.58, which is more than what I have. Oh, you know what I did? I guessed wrong. 0.368 minus the 0.5875 is going to end up with negative 0.2195 moles down here. So you know what? I thought that this guy here was going to be my limiting reagent, and I was wrong. I guessed wrong. So this is one of those examples where you set up, you did the problem, and you did it wrong. And if that's the case, you know what you do? You scrap it and you start over again. And you say to yourself, all right, I'm not going to use the 235. I'm going to use the 368 as my basis. So I'm going to try to use all of the 0.368 to be left with none. Now, if I want to figure out how much of the 235 I used, I come this way, but now I go up by 2/5 because up here I'm going from 5 down to 2. So that's going to be 2/5. And when I do it that way, I end up with 0.147, only that I've used. So if I take the 235 and I subtract the 147 from it, I am left over with 0.088 moles. So I know I did it correctly there. So if you go through and you choose wrong, it's just going to mean that you end up with a leftover that's a negative number, and that can't happen. So try to do your best educated guess with this method. And if you're wrong, you're wrong. You do it over. That's not that big of a deal. But I think if you work on these problems, you'll figure out which one of them is probably going to be the limiting reagent, and you'll get a good instinct for it. All right, now, here's the thing. Just because you have it doesn't mean that you used it and doesn't mean that it's left over. So at this point, the have doesn't matter and the leftover kind of doesn't matter at this point. You want to deal with the used because that's what's actually happening here. So which of these numbers do I use to go over to my HF over here? Because that's where I want to get to over here. Should I use the 368 or should I use the 147? And the answer is sure. Use either one of them you want, because if you do the stoichiometric proportions correctly, it won't matter. Let me prove it to you. Let's say that you're going to do the 368. Now you're going to come over here to the HF. Now there's a 6 there, and you're going from a 5 to a 6. So you're going to have to multiply that by 6/5. And when you do, you end up with an answer of 0.4416. Well, but Smith, what if instead I had used the 147 to get over here? Wouldn't that be a different number? No, it wouldn't. You know why? Because you're going to go from a 2 over to a 6, and so the ratio would be 6 halves. And if you take 6 halves and multiply it by a 0.147, you know what you get really darn close to? 0.4416. So it really doesn't matter which number that you go from if you use your correct stoichiometric proportions. So either way, you have 0.4416 moles that are here, again, depending on where you rounded and so forth. And now you want to get up to grams. So you're going to have to take into account the fact that this stuff weighs 20 grams per mole. Don't use the 6. You already used the 6 here and here. Depending on which way you went, and so you should end up with in the neighborhood of about 8.8 grams of the HF if you have done the problem correctly.